Kia ora. In this video, we're looking at the Mahalanobis distance, a powerful tool in statistics and machine learning. The normal Euclidean distance works great for data with equal variance in all directions. But when your data has correlated variables, the Euclidean distance can be misleading. That's where the Mahalanobis distance steps in. The Mahalanobis distance between 2 points, in this case x and m, is calculated like this. D is the Mahalanobis distance. X is the vector of the particular point we're looking at, or the observation. M is the mean point, which is the mean across the two variables. And c to the power of -1 is the inverse covariance matrix. So let's look at what this formula is doing. X minus m represents the difference between the 2 points. C to the power of -1 is the inverse of the covariance matrix, which scales and rotates the data to account for the correlations and variances. And the square root gives us the final distance. Essentially, Mahalanobis distance measures how many standard deviations away a point is from the mean of the distribution, taking into account the shape of it. This makes it useful for identifying outliers, clustering data, and classification tasks when the data has no uniform spread. So let's look at a couple of practical examples. Here I've got a random data set of almost 2,000 points with no correlation. If I colour these points by the Mahalanobis distance, we can see that it's forming nice circles as the colours go out. If I change the correlation so that there's a strong correlation, you can see instead of there being circles, there's now ellipses being formed. And this becomes a lot more obvious when I really increase the number of points. So if I ramp this up so that there is 100,000 points, you can see those ellipses nicely stretching with the shape of the data. Whereas when there is no correlation, you can see that it forms nice circles. So what the Mahalanobis distance is doing is it's identifying those points that are furthest away from the general spread of the data, even when the data is highly correlated.